Okay, so we are going to continue doing solving systems using elimination, and we are going to be doing a little bit harder problems today. Okay, so I'm going to link some more to the other videos, but I'm going to do 2 examples with you, and then tomorrow, Friday, you will have more practice on these types of problems. Okay, and we'll get to the IXL tomorrow. That way. You can like kind of get the explanation from them, but we had to build up all the way to it. Okay, so we're still doing elimination. Literally want to eliminate. If I stack these and add, 3x plus 5x, 8x does not work. Negative 2y plus 3y, 1y does not work. It does not go away. Okay, so we are going to have to eliminate a variable. My question is, does it matter which variable? And the answer is no. One of them sometimes may be easier than the other, but you can always just do either, or it does not matter at all. So we are looking for the least common multiple, if you remember that. And so I'm going to look at these x's. These are not the same number. If we want them to eliminate, we got to get them to the same number, and we want to use the least one to make all of our numbers smaller. So what is the smallest number that 3 and 5 both go into? Not going to them. What do they go into? And so it is 15, okay? And then if I do the same type thing for y, and I'm looking at these numbers, the smallest number that they both go into, remember, a number can never go down. It can only go up. It is 6. So if I'm trying to pick which variable to eliminate, I'm going to pick the smaller number most of the time, okay? And so this time I'm going to choose to eliminate y. And my kicker from yesterday is, guess what? They already have opposite signs, and that's what we need. So we don't have to worry about the signs. We just got to worry about the numbers. So if I'm trying to get 2 up to 6, what do I have to multiply this whole top row by? 3. And if I'm trying to get 3 up to 6, what do I have to multiply this whole bottom row by? 2. So this is the first problem where we're actually having to like do something to both equations to get them to what we need, and that's totally okay. So I'm going to multiply everything by 3 on the top row, and I have 9x minus 6y equals 12. And I have 10x plus 6y equals negative 50, okay? And remember, the reason we didn't have to multiply by negative is because they already had different signs. And so we stack and add, and we get 19x. And what do you see happens right here? It eliminates. Is that what we were trying to do? Yes, it was. That's a 19. That looks bad. Equals, what is that? Negative 38. Okay, I need to divide both sides by 19. And I get x equals negative 2. Okay, but remember, in these systems, we are trying to figure out where these things intersect on a graph. We did it graphing, and we saw it. We did it substitution, and now we're in elimination. And so I've got x, I still need y. So I'm going to take this x, and remind me from yesterday, does it matter which one you go into, the top or the bottom? Absolutely not. And I told you I usually like to go into the top. So I'm going to stick this and put it in for x, because it says x equals that. So now I have 3 times negative 2 minus 2y equals 4. I did sub it into that top equation, and I just solved. Negative 6 minus 2y equals 4. Add it over. Negative 2y equals 10. And divide both sides by negative 2, and I get y equals negative 5. So again, I've done all of this work. It would be a shame for me to not get this answer correct, because I did not write it as a coordinate point, an ordered pair. And remember, it does go x and then y, and so my answer is the point negative 2, negative 5. It does have to be written in parentheses, it does have to have the comma. This means it is a location on a graph. So if I was to graph both of these things, that's where they're intersecting, okay, is that point. All right, pause me, review me if you have questions on this first problem. I'm about to move on to the second one, okay? All right, so again, we're doing elimination, and I want to eliminate either x or y. Totally does not matter. You get to choose. And so I see that if I stack and add, neither of these variables are eliminating. Question, do I care about the numbers? No, I'm trying to get rid of a variable, so I'm only looking at those two, okay? So the smallest number that 5 and 7 go into is 35. All right. What about 4 and 6? Some of you may say 24. Would 24 work? Yes, because it is a common multiple. But one that might be a little bit easier for us would be 12. How come? Because that is the least one that they go into. 4 and 6 both go into 12. So if you want to get rid of x and get these numbers up to 35, you totally can. But I am going to choose y again, just happened to be y again, because 12 is smaller, and I'd rather deal with smaller numbers. So if I'm trying to get 4 up to 12, I need to multiply this whole row, this whole top row, by 3. If I'm trying to get 6 up to 12, I need to multiply the whole bottom row by 2. And I want to hit back on the first one. This is just totally coincidental that that happened. And I did choose to eliminate y first in both of them. It does not matter, okay? Totally coincidental, 3 and 2. Do I need to tack on a negative to either one of these? No, because they are already opposite signs. Question, would it matter which one I tacked it onto? No, you can choose, okay? So I'm going to rewrite these things with doing my manipulation to it. So 3 times 5x, I'm going to have 15x plus 12y equals 36. And I'm going to have 14x minus 12y equals 80. Stack and add, and I get 19x. No, I don't. I get 29x. Do they eliminate? Yes, they do. That's what we wanted. Equals, oh gosh, what is that? 16, I think. Yeah, okay. I need to divide both by 29. And I actually can't use my calculator because I'm on my phone. And I'm not sure exactly how many times that goes into. So I'm going to process this whole thing. So a number really close to 29 would be 30. And 30 times 3 is 90. 30 times 4 is 120. So I think 29 times 4 is going to be that. So I want to check that. Just using some reasoning skills right here, which we probably should practice on. And that is correct. So I get x equals 4. All right, I've got x. What do I still need? I need y, so I'm going to sub this x back into which variable? X, into one of my original. Does it matter which one? No, I'm going to go into the bottom to show you can, but it does not matter. Okay, and so I'm going to actually put the phone down really quick because it's starting to shift on me, and I'm going to sub this in. Give me like 10 seconds. Alright, and here is my work for that. So I did, let's let it focus. I did sub in there my 4 into x because it says x equals that. And so 7 times 4 minus 6y equals 40. I just solved for y, and I got y equals -2. And then I'm going to write this as an ordered pair. And so my answer is 4, -2.